Okay, good morning. Sorry if my voice doesn't sound too good. Don't know why, but hopefully you can at least hear me on the video here. So we're talking about similar triangles using a theorem called angle-angle postulate. Okay, and this is basically just simply saying that you got two angles. If two angles of one triangle are congruent to two angles of another, then the two are similar. That doesn't mean they're equal sized triangles, it just means they're similar. Okay, so kind of for example, if I drew a real small diagram here, if I have this angle and this angle, or triangles, if I have a 90 here and a 90 here, that's one angle. And then if I told you that this angle and this angle are equal, that makes one set and two sets equal, which would mean that these two triangles, we'll just call this triangle 1, is congruent, or similar, I'm sorry, to triangle 2. All right, so you just need two sets of angles that are equal, and you can use that it's congruent. So in this first example, we want to determine are these two triangles going to be similar? All right. Now notice here right away you've got a couple 90-degree angles. So there's one pair right here, okay? But we're given, this is 50 and this is 45. So we need to figure out what angle P and what angle S is. And all we're going to do, remember there's 180 degrees in a triangle, right? So let's take the triangle, let's focus on this guy on the left, PQR. All right. So we're going to say, okay, 180 minus 140, because if I add 50 and 90, that gives me 140 degrees. So that's going to tell me this is 40 degrees. So angle P is 40. Now let's figure out S. So we're going to take 180, subtract. You got 90 and 45, so that's going to be 100. Oops, need a pen there. 135. So you're going to subtract, it's going to be a 7, make him a 10, that's a 5, and that's a 4. So S is 45 degrees. So my question is to you, do we have two angles that are equal? You got the 90, whoops, how about a different color than black here? We got the 90 here and the 90 here, and I don't see anything else here, do we? So because these two aren't equal and these two aren't equal, the answer here would be no. They're not similar, okay, because you need two sets of angles. We only have one. Okay, so that's for the first example. We need two sets of angles that are equal. All right. This second one, the best thing to do on this one, again, we've got triangles that are overlapped. You got a little one and then a much bigger one. So let's draw the little one. There he is, and then let's draw the bigger one. Okay, so here's U, X, W. Here's U. I'm sorry, let's go back. This is Y. And this is V. I looked at the wrong one. Sorry, guys. This one is X and W. So this is 35 degrees. U is 35 degrees, and notice that U is used in both triangles. We also know that Y is a 90 and X is a 90. So do we have two sets of angles? Well, let's compare. We got U. Oh, it's stupid. It always goes to black. We got U and angle U, and then a 90 degree here with Y and a 90 degree here with X. So do we have two sets? Yeah, we do. So this would be a yes. So you would say triangle U, Y, V, V, not X, is similar to triangle U, X, W. Big tip here is by reflexive property, angle U is used in both, isn't he? Okay, so he's overlapped. So even if we didn't know that this was 35 degrees, we know that angle U would be equal to angle U, right? So we could use it in either triangle. Okay, so if they didn't give us this one and only gave us these, we could still say they're similar because we know no matter how many degrees these two are, they're going to have to be equal to each other because it's the same angle used in two different ones. Okay, moving on. Okay, let's talk about one of my favorite sports is ice hockey. This looks like a Pittsburgh Penguins picture to me. By the way, they beat the Red Wings 6-3 last night. You know, basically, if we look at these two triangles, B and E are equal to each other, right? So that's one set of similar or congruent angles. And then here's the other thing. Physics tells us that whatever angle the puck would come in at, and when it bounces off the wall, it's going to be coming off at the same angle. So if he were to shoot from over here, let's say this is coming in at a 30-degree angle, it's going to go off at a 30-degree angle. All right? So even though they don't give us how many degrees the puck is coming in to bounce off the wall, we know because of physics it's going to have to bounce off the same. All right? So angle C is really going to be equal with himself here. So they are similar triangles. Now, in the book here, it kind of tells us, it wants us to write a proportion. Okay? So what we're going to do is this. And the reason why they're wanting us to write a proportion is they want us to figure out how far away is this hockey player from the wall. Okay, and that's why they call him X. So we set up a proportion. We're going to say little triangle X over big triangle 25. Okay. And why did I set those equal to each other? Because they're corresponding parts, right? Is going to be equal to, we're going to say 28 over 40. Again, small triangle over the big one. All right. Now we cross multiply. So we're going to have 40x is equal to, yep, I'm cheating. I'm looking out of the book. 700. We divide by 40. And x is going to equal 17.5. And that would be feet, because they do give you a unit of measure. So you best make sure you give it a unit of measure. So this is 17.5 feet. That's how far the hockey player is away from the wall. Simple physics. Love physics. Hope you do too. All right. That is the general gist of this lesson. Okay. Again, we've got to have, in order for two triangles to be similar, okay, no matter what their size, as long as you have at least two angles that are congruent, like we do here, then the triangles are similar to each other. They're not equal. They're similar in size and shape. All right? Do have a great rest of your day. See ya.